In this demonstration, I would like to show how a CarBot, a CM-5 based CarBot, using an AX-S1 ID100 for the node to sense the near infrared, for AX-12 for the wheel as usual. In this one, it shows a solution when we take the reactive control approach. So the program start out. We have separate speed 1, 2, 3, 4. This is mainly so that we can make sure, in case we need to adjust individual speed to make sure it goes straight when we want to go straight. The speed is used, of course, in various functions. To move forward, I mean 1 and 3 go clockwise, 2 and 4 go counterclockwise at different speed. So right now they are the same, but if it doesn't go straight, we need to adjust. Okay, so these are the basic function of move left, move right, and then so another things. First, it set up the threshold for ID100, which is the AX-S1. It set up to 150. That means everything that is when the data reads in from the three right, center, left of the AX-S1, where the data read more than 150, we'll set up the flag to equal to 1. That means say, oh yeah, you got an object on that side of my sensor. Next, we call initialize. And initialize essentially have a for loop to make sure that all the AX-12 are set up to wheel mode, which is then essentially write 0 to address 8. So once we've done that, and then we got the big endless loop, essentially picked up whatever the flag is, which is the object detected flag, saved to parameter called direct, and then it's an if-else-if structure. Because this is the reactive control, usually this means that we want to choose one alternative among many, only one and only one. So the best logical structure for that is the if-else-if structures. And you can see, you can read in the book that there are actually 1, 2, 3, 4, 5, 6, 7, 8 possible situation, and for each of the situation we have one and one only unique action. Well, action is not perfectly unique. Okay, so like for example, if the object detected flag, which is a direct parameter, read all 0, that means there's nothing in front of it, to the right side, to the left side. Obviously, we can ask the robot to go forward. So in this example, the robot will be autonomous. Let's say if we read something in front of it, so you have to remember it's the lowest bit corresponds to the left side. It's over here. Second digit from the left is the center, and then for the right side, it's the third digit from the right. So therefore, you see, when everything is clear, obviously you go forward. If something in the middle, you want to go backward. If something on the left of you, obviously you want to go right. And if something to the right of you, to the robot that is, you want to move left, obviously. Okay, so that's all the code is. And right now I'm using just good old wire connection CM-5. So make sure you have that download. It's working. So I need to turn it off. Be safe to take connection out. Put it on again. So change it to run mode. And now we're ready to play. So immediately gonna go forward. So it will detect running. And then put a key on in front of it. But if I put my hand in secundo, it does go back and forth. So it does kind of somewhat unintelligent behavior here, but mainly that's because my fault. So when there's something in front of it, we'll go back a little bit. But when I go back a little bit, the sensor would not read anything anymore. So therefore I go forward again, and then it sends something, it go backward, forward, backward. So it's bouncing between these two cases. And it doesn't look very intelligent, obviously. That's basically the programmer fault, you know, not the bot. So you can see that instead of just going backward, maybe you can go backward and turn left or turn right a little bit, perhaps. So that's some of the approach we're going to do when we go to the smart avoider approach.